11.3b, Systems of Equations. It's kind of the second day. Going through what we did yesterday, we're going to model certain situations with linear and quadratics, and we're going to solve them using technology. Here we go. A lot of these things here aren't going to be nice whole numbered answers, and that's kind of the big reason why we're using technology. What I want to stress is in these equations, they're using different variables other than x and y. They're going to use h and t. So a rocket is launched from the ground and follows a parabolic, so a parabola path represented by the equation h equals negative 0.2 t squared plus 1.5 t plus 4. At the same time, a flare is launched from a height of 5 feet and follows the path of h equals negative 2t plus 5. Sketch the graph and represents those two. So if h is going to represent any given height. Let's see if we can get this going. So h would be the height of the rocket. That's basically y. So when I go over here to my Desmos, and that's all I did is pull this off to the side, I'm going to put y equals, okay, now over here t is going to be a time, and that's going to be your x. So y equals negative 0.2 x to the second power plus, and I'm just going to continue to put that in. Remember, if you don't see the parabola, you might have forgot the x or the x squared. I'll put that in there, plus 4. There's my parabola. I'm going to go down to the second one, and I'm going to put in my line. Y equals negative 2x plus 5. Okay, so here we go. I am going to find where they intersect, and what I like about this program is I can just kind of hit that dot, and their point of intersection, 0.291, 4.419. And what that means is that after 0.29 seconds, they meet 0.4 feet off the ground. Okay, and that is the idea of what we're doing here. We'll try one out here. Here's talking about baseball. Now the only thing is they're talking about a baseball being height in meters. That's no big deal. That just means when you read out your answer, make sure you have it in meters. T is going to be in seconds. It's going to be tossed out a window at this parabola here. So I'm going to go and I'm going to clear out my two graphs, and I'm going to put in my parabola again. So y equals, again, y is going to take the place of h. Negative 5, x is going to replace t, so x squared plus 24x plus 12. Okay, and then I've got my line of a trajectory of a paintball gun. So this paintball gun is going to follow the line, and I'm going to go with y instead of h equals 6x plus 4. Okay. Now on Desmos here, I don't quite see them. I just put the double arrows, and that puts the equations down below. I don't see where they intersect. Well, I guess I do, but one of them is going to be at, better pull that up again. A negative 0.4, 1.6. Okay, I'm going to scroll this up, and I'm going to find the other one of 4,28. Now, this one won't work because negative 0.4 means negative 0.4 seconds, and we can't have negative time. So the actual solution is that after 4 seconds, the balls meet at 28 meters off the ground. Okay, now that green just means that it went up eventually, and it is going to come back down. So on the way back down, that baseball gets hit by the paintball of that line here in purple. So that's kind of the idea. You're just going to graph the two equations and find out where they meet. Now, sometimes they might meet twice. Sometimes they might meet only once. Sometimes they don't meet at all. But we're looking for sure positive time. And heck, maybe we have to think a little bit about what's going on with the problem to find out which one's the actual realistic solution.